Greetings to dear students. We are seeing the problems regarding the residues. So in this video also, we are going to continue to find the residue of the given function at the point. Okay. So here, find the residue of cot z at the point z equal to 0. So they have given the point where we need to find the residue. Okay. So let us take the cot z as f of z. Cot z can be written as cos z by sin z. So sin z, clearly 0 is a pole for f of z of order 1. Okay. So what are the poles of f of z? What are the poles are sin z? All 2n plus 1 into all n z, isn't it? Okay, all in sin n z is all poles for f of z. Poles for sin z, because when n equal to 1, sin z 0. When n equal to 2 z, in general, sin n z is equal to 0. So all n z is the poles for the function sin z. But here they are asking to find the residue at the point z equal to 0 only. Okay, so 0 is a pole for f of z of order 1. Since the denominator part does not have any terms as z minus something, we have to go with the formula 3. So the residue of f of z at the point 0 is h of 0 by k dash of 0, where h of z is the terms in the numerator, k of z is the terms in the denominator. Now we are checking h of 0 whether it's not equal to 0 and k of 0 is equal to 0. So h of 0 is equal to cos 0. The value of cos 0 is 1. So therefore h of 0 not equal to 0. K of 0 is equal to sin 0, which is equal to 0. So it satisfies the condition in the statement. So we can apply this formula to find the residue of f of z at the point 0. So here we need the differentiation of k of z. So let us find the differentiation of k of z. Therefore, k dash of z is equal to, since k of z is equal to sin z, k dash of z is cos z. So substitute the value 0 in the place z, k dash of 0 is equal to 1. So h of 0 equal to 1 and k dash of 0 is equal to 1. Therefore, residue value is 1 by 1 is equal to 1. Okay. So it's an easy problem only. So the next problem, find the residue of e power z by z square plus z square into z square plus 9 at its poles. Okay. We have to find the residue of the given function in all its poles. Okay. So first let us find the poles. So first let us take the given function as f of z. So f of z is equal to e power z by z square plus 9, which is equal to z square plus 9 can be written as z plus 3i into z minus 3i. So here 0 is a pole for the function f of z of order 2, as it contains 2 here. 3i and minus 3i is a pole for the function f of z of order 1. So for this, we have to go with formula 4. And for these two, we can go with the formula 2. Okay. So now find the residue of the function f of z at the point 0. Since it is a pole of order greater than 1, we have to go with formula 4. What is formula 4? If f of z is equal to g of z by z minus a the whole power m, then the residue at the point a is equal to g power m minus 1 of a by m minus 1 factorial. Here we have the order as 2. So therefore, residue of f of z at the point 0 is g dash of 0 by 1 factorial. Since it is of order 2, we have g dash. Okay, one time differentiation. So first we need to find the value of g dash of z. Before that, what is g of z? Leaving these thing alone in the denominator, taking all the remaining things as g of z. Okay, so g of z is e power z by z plus 3i into z minus 3i. Z plus 3i into z minus 3i is nothing but z square plus 9. So this is what I have. So that is why I have written z square plus 9 here. So g of z is equal to e power z by z square plus 9. So this term contains z and this term contains z. So we are going with u by v method. What is u by v? Differentiation of u by v is equal to v u dash minus u v dash divided by v square. So by using this formula, we obtain g dash of z as this. Now we substitute the value 0. So g dash of 0 is equal to e power 0 into 9 minus e power 0 divided by 9 square. As e power 0 equal to 1, the first term, this will become 9. This will become 0. So 9 by 9 square 81 is equal to 1 by 9. So therefore residue of f of z at the point 0 is g dash of 0 by 1 factorial. G dash of 0 is 1 by 9 divided by 1 factorial, which is equal to 1 by 9. Okay, so next we find the residue at the remaining 2 points. Residue of f of z at the point 3i, which is equal to g of 3a. I'm going with the second formula. So then what is g of z? Except z minus 3i, all the remaining terms will become g of z. Will now g of z. Okay. Since because I am finding the residue at the point 3i, so except z minus 3i, all the remaining terms will be g of z. So g of z is e power z by z square plus 3i. Now the residue of f of z is g of 3i. So in the place z substitute 3i, we get e power 3i by 3i square into 6i. E power 3i, that is e power I theta is equal to cos theta plus I sin theta. We know that e power I theta is equal to cos theta plus I sin theta. We know that. So in the place theta, we have 3. So substitute 3 here. So cos 3 plus I sin 3 divided by 3 square 9 minus I square is minus 1 into 6i. As I shouldn't come in the denominator part, we are multiplied and divided by I. We get the numerator part will now have the I. The denominator part, we have I square. So I square is minus 1. So minus and minus will become plus 9 into 6, 54. So therefore, residue of f of z at the point 3i is I into cos 3 plus I sin 3 divided by 54. Okay. So next we find the residue of at the point minus 3i. So here I'm going with the second formula. So here g of z is except z plus 3i, all the remaining terms will be g of z. So in that g of z, substitute z, replace z by minus 3i. We will get e power minus 3i by minus 3i the whole square into minus 6i. So e power e power I theta is equal to as cos theta plus I sin theta. Here in the place of theta, we have minus 3. So cos of minus 3 plus I sin of minus 3. As we know that cos of minus theta is equal to cos theta, sin of minus theta is equal to minus sin theta. The numerator will become cos 3 minus I sin 3. The denominator is minus 54i. When we multiply and divided by I, the residue of f of z at the point minus 3i will become I into cos 3 minus I sin 3 divided by 54. Okay. Okay. So according to the problem, we have to use the formula wisely. Okay. So if the denominator part, if the function f of z have the term z minus a, then you can go with the formula 2, second formula. If it is a pole of order greater than 1, then you must go with the fourth formula. Okay. So I hope these two problems I have taken here is clear to you all. We will see the remaining 3 problems in the next video. Okay. So thank you. Thank you, dear students. Thank you.